Okay, good morning, class. Okay, it's afternoon now. Okay, it's 12 o'clock. Alright, so here we go. The last part of this chapter, which is the examples for exercise 3.4. Okay, so you guys haven't watched this video yet, so the full lesson can be found in the description box below. Okay. So we're looking at the examples for exercise 3.4, which is on page 77. Right. And this example, which is on page 76. So now we're looking at geometric patterns of a quadratic sequences. A number that can be represented as the number of dots in triangular array is called a triangular number. Okay, so that you don't really need to know. However, in triangular numbers, it was exposed to you in grade 10 already. I don't know if I've told you, I don't understand how they expect you to know or to have worked out the triangular numbers, because in grade 11, we actually follow the formula we are given here, which is a quadratic formula. Okay. I also had a look at a lesson dealing with triangular numbers, and a learner doesn't think in that manner. Okay. Maybe you're a very, very good learner. No? Which is most of you, but you guys also think so. But anyway, we were looking at stage 1. How many dots we have here? 1, then 3, then 6, then 10. Okay. The question says determine the general term of the sequence generated by the number of dots in any triangle in terms of the stage number. So the first term is stage 1. Stage 2 is the second term. Stage 3, third term. Stage 4, fourth term. Stage 8, eighth term. Stage N, nth term. You guys understand? So the stage number, pattern number, array number, whatever, it is the same as your term number. You guys understand? So whenever you are given a geometric pattern, be it dots, or be it another one is using dots, one is using triangles, one is using boxes, one using blocks, one using whatever they use, people, whatever it might be, I convert that drawing or that diagram, I convert it to numbers. By converting it to numbers, then is as if we are dealing with any of the previous sections or previous exercises that you were exposed to. You understand? So once you can write that number, the sequence of numbers properly, you can then do anything with it. Not so. So let's look at this example here. We have 1. Stage 1 is 1. So how many? So what number goes here? 1. Then 3. Then 6. There's 6 dots here. And why am I counting the dots? Because we need to generate a general term of the sequence that generates a number of dots. That's why I'm going with dots. Okay. 6. Then 10. What if the question is to draw the next sequence? What if you have to draw the next sequence? Then how many dots will there be for stage 5? Stage 5. So you'll have 1, 2, 3, 4. So it's going to be 1, 2, 3, 4, 5. So let's just draw that. If you say stage 6, then I'm just going to have an additional row. Stage 7, additional row. Stage 12, the bottom row will have 12 dots. You guys understand? So if the question was, what is the next terms in your sequence, what would this be? 10, then 15, then 21. As you can see, it's 6. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And you see, you guys understand? People, if they ask you to work out the general term, we must check our difference. We have a difference line. So how do I move from one term to the next? 3 minus 1 is 2. 6 minus 3 is 3. 4. 5. 6. People, is this a constant first difference? No. So what do I see here? 1, 1, 1. So it doesn't have a constant second difference. Yes. So it makes this pattern a quadratic pattern. What is the general term for quadratic pattern? dn is equal to an squared plus bn plus c. What do I write on the side? 2a, 3a plus b, a plus b plus, bottoms up, that direction. Not so? Right. So what do I write on the side? 2a is equal to 1. So a is equal to half. So I now go here. A is now half. So 3 times a half plus b is equal to 2. So it's going to be 2 minus 1.5, which is a half. Oh, not negative. No? Then what do we know? A plus b plus c is 1. So it's a half plus a half plus c is equal to 1. What's half plus half? 1. So c is equal to 0. So what's my formula? Tn is equal to half n squared plus half n plus 0, which is that. People is worth 4 marks. What do I do? Check. So we go. I'm going to test for term 3. So it's going to be a half times 3 squared plus a half times 3. The answer should be 6 to be correct. Not so? Let's see. 6. Now I feel better about myself. Not so, people? If they ask you, and I know we didn't cover a question like this, they could ask you, they can ask you, thank you, which term of the sequence equals which term of the sequence, or which term number, or which stage number has 1000, number on question, eh? Which stage number has 1275 dots in it? Which stage number has 1275? People, am I going to extend this pattern to till I get 1275? Not in this lifetime. Not so. We got better things to do. Right, so what do? We're going to set the general term equal to 1275. By doing that, I then get half n squared plus half n equals 1275. Bring that over the equal sign. I get the half n squared plus half n minus 1275 equals 0. I say, hang on, what is this? Quadratic. And what do I do for quadratic formula? I use the quadratic. Sorry. What do I do for a quadratic equation? Use the. There we go. I'm giving you the answer. I'm getting excited about this stuff. No? For the quadratic equation, I use a quadratic formula, or complete the square, or use the factors, or silver. Yes. This is the best thing for me. So I go half, and negative 1275. Give me an answer. 50. So n is equal to 50, or n is equal to negative 51. People, can we have a position number or stage number at negative 51? Of course not. So you say, therefore, is stage 50, or the 50th term, is equal to 1260. You guys understand? What if they asked you, let's spice up your life a bit. What if they ask you, which position is 2450? Which sequence, or which, what's the word they used earlier? Stage. Which stage number has 2450 dots? what we do? Same thing as we did here, not so? So it's going to be a half inch squared plus a half inch equals 2450. So I take it over the equal sign. So it's a half inch squared plus a half inch minus 2450 equals 0. They say, okay, what do we do from here? Quadratic formula, not so. But I am a bit fortunate. This was given to me for free. So we go a half for your A value, a half for your B, and then negative 2450. So, what do we know about n? What do we know about n? Firstly, it must be positive, which is the case here. What else do we know about n? Can't be decimal this. It can't be this one. It can't be that one either. So what does that mean? That means to say, therefore, no solution. Which means to say what? There's no position number, or there's no stage number that has 2450 dots. You understand? So just bring it a bit closer to home. I would ask you, which stage number has 9 dots in it? Is there any stage number that has 9 dots? Make so? No. Okay? That answer will come to be 3 comma something. Can you see that, people? It will be between 3 and 4. But is there a stage that has 9 dots in it? Exactly 9 dots? No. So your solution will look as it looks here. You guys understand?
Yes.
And that's how it goes. Okay. People, the full lesson can be found in the description box below, and this also brings us to the end of chapter on number patterns.